So today's lesson is 4-2. What we're going to be talking about are arithmetic, geometric, and neither sequences. You're going to also have to find the common difference and the common ratio. So what an arithmetic sequence is, all right? An arithmetic sequence is adding or subtracting the same number each time. So the big thing here is adding or subtracting the same number each time. The common difference is the actual number that you're adding or subtracting each time. So if, for example, we were adding by 5, we had a pattern that we were adding by 5 each time, 5, 10, 15, 20. That would be an arithmetic sequence because we're adding by the same number each time. And then your common difference, D, would be a 5 because we're adding by 5 each time. If we had a pattern that we were subtracting by 1 each time, for example, if we had 10, 9, 8, 7, 6, 5, 4, that would be an arithmetic sequence also because we're subtracting by the same number each time. And the common difference would be a -1 because we're subtracting by 1 each time. So let's take a look. We're going to do a whole bunch of examples today. Let's take a look at this first one, 2, 5, 8, 11. So what you have to do is you have to find the next 3 numbers in the sequence and identify your common difference. So to get from 2 to 5 to 8 to 11, we are adding by 3 each time. Since we're adding by 3 each time, our common difference would be a 3. Now to continue on with the pattern, we would have 11 plus 3. 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20. So this would be an arithmetic sequence because we're adding by 3 each time. 100, 95, 90, 85. What we're doing each time is subtracting by 5. You could also say that it would be adding by -5. Those mean the same thing. But we're subtracting by 5 each time. So 85 minus 5 is 80. Minus 5 is 75. Minus 5 is 70. 5, 6.5, 8, 9.5. So what we're doing each time is we are adding by 1.5 or 1.5. So if we're adding by 1.5 each time, 9.5 plus 1.5 is 11. Plus 1.5 again would be 12.5. Plus 1.5 again would be 14. So we're adding by 1.5 each time. Now, one of the ways that if you can't figure out what you're adding by, all right, what you can do is actually work backwards. One of the things that you can do to try and figure out what your common difference is just take 2 of the numbers in the pattern and subtract going backwards. You could just subtract going backwards. If you did 11 minus 8, that's going to give you your common difference of 3. If you do 85 minus 90, 85 minus 90 gives you your -5 or -5. 8 minus 6.5. 8 minus 6.5 gives you your common difference of 1.5. So if it's an arithmetic sequence, if you can't figure out what you're adding by or what you're subtracting by each time, just work backwards. Take any 2 of the numbers and subtract going backwards. That will give you your common difference. The next kind of sequence is a geometric sequence. Geometric sequences are multiplying by the same number each time. Again, it's the same number. Now, where arithmetic sequences we're adding or subtracting, geometric are only multiplying. We are multiplying by the same number each time. And this is the number, all right, the common ratio is the number being multiplied by each time. So just like the common difference was the number that was being added or subtracted each time, the common ratio, your R value, is the number being multiplied by each time. So some of these are easy. Some of them are a little bit more complicated, all right? So if we have 2, 6, 18, 54, how do you get from 2 to 6? How do you get from 6 to 18? How do you get from 18 to 54? Well, what we're doing each time is that we are multiplying by 3 each time. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, 54 times 3 is 162, 162 times 3 is 486, 486 times 3 is 1,458. Our ratio is 3. Some of these numbers get pretty big pretty quickly because we are multiplying. Now, be careful. Notice in this next one, we have alternating positive and negative numbers. That's your first clue that you're multiplying by a negative. Because remember, a negative times a negative is a positive, but a negative times a positive is a negative. So when you see this alternating pattern of positive, negative, that's your first clue that you're multiplying by a negative. So how do you get from 2 to 10 to 50 to 250? Well, what we're doing is that we are multiplying by -5 each time. So -5 would be our common ratio. 250 times -5 is -1250. -1250 times -5 is 6,250. And then that times -5 gives you -31,250. Be very careful here. 1/2, 3/2, 9/2, 27/2. All that we are doing, notice that your denominator is staying the same. All that we are really doing is multiplying by 3 each time. Technically, you could also say that we're multiplying by 3 over 1. That would be fine to say it that way as well. Well, all we're really doing is multiplying by 3 each time. So 3 would be our common ratio. So this would end up being 81 over 2. Multiply that by 3, it would be 243 over 2. And then this would be 729 over 2. You could either say we're multiplying by 3 or 3 over 1. Now, be careful when the numbers go down like this next one. 2,500, 125, 31.25. Because we're multiplying, all right, when the numbers are going down, that's your signal that you're multiplying by a number that is less than 1. You're multiplying by a number that's less than 1. There is that little trick, just like we had with the arithmetic sequences. You could go backwards and divide the numbers, all right? If you want to try and figure out your R value, you can figure it out by dividing going backwards. So we could do 54 divided by 18. We could do 18 divided by 6. We could do 6 divided by 2. All of those give us 3. So when it's one like this, I would just take these two numbers and divide them going backwards. 500 divided by 2,000. 500 divided by 2,000 is 0.25. 125 divided by 500 is 0.25. 31.25 divided by 125 is 0.25. So our R value is really 0.25. That's what we're multiplying by each time here. So if we continued out with this pattern, you're going to get big, long, ugly decimals. 7.5, 8125. And then you would have 1.953125. Multiply that by 0.25, you get another big, long, ugly decimal, and so on and so forth. So again, if you can't figure out the pattern, just go backwards and divide. If it's arithmetic, just go backwards and subtract. Now, one of the other things you have to be careful of is you can't say dividing by 4. It's very, very tempting in like this last problem. Some of you might have thought, well, how do I get from 2,000 to 500? I'm dividing by 4. You can't say dividing in any of this, all right? You can't say dividing. Geometric sequences are multiplying only. You can't say dividing, all right? Now, if you think that you are dividing by 2 each time, so maybe we started off with 100 and you had a pattern that said 100, then 50, then 25, then 12.5, and so on and so forth, and you thought that you were dividing by 2, dividing by 2 and multiplying by 1/2 or 0.5 is the same exact thing. Dividing by 3, if you think your pattern is dividing by 3 each time, that is the same thing as multiplying by 1/3 or 0.3 repeating. If you thought that the pattern is dividing by 5, that's the same thing as multiplying by 1/4 or 0.25, and so on and so forth, all right? So if you think that you are dividing by a number, you can't put dividing as your common ratio. You have to put the multiplying by whatever the decimal is. So be very careful there. Now, the next one, in the next part, you have to decide, all right, there's really 2 separate problems here. I'll just hide half the screen so it's easier to see. This is a typical question on your homework today. All right, you're being given a pattern. You have to decide whether the pattern, what the pattern is. You have to find the next 3 numbers in the pattern. All right, what the pattern is, whether it's arithmetic, geometric, or neither. And then depending on if it's arithmetic, you have to find the common difference. If it's geometric, you have to find the common ratio. So 45 to 90 to 180 to 360. I can tell right away that it's not going to be arithmetic, because I'm not adding by the same thing each time. There's a difference of 90 here, but there's a difference of 180 here. So I know that it's not going to be arithmetic because I'm not adding by the same thing each time. Therefore, I know that it has to be geometric. All right, so I want to find the common ratio. How do I get from 45 to 90, from 90 to 180, from 180 to 360? Well, what you're doing each time is that you are multiplying by 2 each time. So 2 would be your common ratio. So we are multiplying by 2 each time. So if you couldn't figure out that you're multiplying by 2, remember the little trick. You can divide going backwards. If you type into your calculator 90 divided by 45, that will give you 2, which is your ratio. So keeping on with the pattern, 360 times 2 gives you 720. 720 times 2 gives you 1,440. That times 2 gives you 2,880. In the next one, we have -4, -2, 0, 2. So what you're doing each time is that you are adding by 2. You're adding by 2 each time. So this is going to be an arithmetic sequence. Our common difference is going to be 2 because that's what we're adding by each time. Again, if you couldn't tell what it was, you could take 2 numbers and subtract going backwards. 2 minus 0 is 2. 0 minus -2 is 2. So we would keep on adding by 2. So this is going to be 4. 4 plus 2 is 6. 6 plus 2 is 8. Take a look at the next one. In this next one, we have -2, -6, -18, -54. I can tell right away that it is not arithmetic. It's not arithmetic because there's a bigger gap in between -18 and -54 than there is in between -2 and -6. So I know right away that this has to be either geometric or neither. I'm going to divide going backwards. Choose any two numbers and divide going backwards. -6 divided by -2, -6 divided by -2 gives you a +3. So I know right away that this is geometric. I'm multiplying by 3 each time. Times 3, times 3, times 3. I'm multiplying by 3 each time. So keeping on with our pattern, multiplying by 3, this would be -162, -486, -1458. Now, take a look at this next one. This next one is tricky. I'm going to tell you right away that this is going to be a neither pattern. All right, what a neither pattern looks like is it is a weird pattern. It's not arithmetic. It's not geometric. It's not arithmetic. Well, how do I get from 2 to 5 to 10 to 17? All right, if I use that little trick of subtracting going backwards, I can tell that there's a difference of 3 here. There's a difference of 5 here. And there's a difference of 7 here. Well, you might be thinking, well, maybe I'm dividing by or multiplying by a certain number each time. Well, when you do 5 divided by 2, you get 2.5. If I do 10 divided by 5, you're multiplying by 2. So these are not the same. Therefore, I know it's not geometric. These are not the same. I know it's not arithmetic. That means it has to be neither. Well, this is actually the pattern that you have here. We're adding by 3, adding by 5, adding by 7. If we keep on with that pattern, it's increasing by 2 each time that we're adding. All right, increasing by 2 and adding. So +7 + 9. So this is going to be 26. +11. This is going to be 37. +13. This is going to be 50. So this is a neither pattern. Now, why it's not arithmetic is because we're adding by different numbers each time. Remember that arithmetic is adding by the same number each time. So this is adding by a different number each time. Therefore, it is a neither pattern. Go ahead and try this one on your own, please. Go ahead and try this one on your own. My suggestion is anytime that you have a fraction like this, change them to be decimals. So instead of using 7/4, I would just use 1.75. Instead of using -1/2, I would use -0.5. Instead of -11/4, I would use -2.75. So I would just ignore the fractions and just use the decimals. So to get from 4 to 1.75, and then to get from 1.75 to -0.5, and to get from -0.5 to -2.75, what I'm actually doing each time is subtracting by 2.25 each time. Therefore, this would be arithmetic. Our D would be -2.25. Now, how could I figure that out? Remember to use the little trick of subtracting going backwards. 1.75 minus 4 equals -2.25. negative 0.5 minus 1.75 equals negative 2.25. If I do the last one, negative 2.75 minus negative 0.5, I get negative 2.25. So just subtract the numbers going backwards. If we continue on with the pattern, you would have had a negative 5, negative 7.25, and negative 9.5. That one was a little bit tricky. Go ahead and try this next one, please. So this next one looks a little bit tricky. I see that I'm going from 1,234 to 123 to 12 to 1. So clearly it's not going to be arithmetic because I'm not adding or subtracting by the same number each time. So the next thing that I would try is geometric. So I can't tell what I'm multiplying by. I can see that my decimal point is moving each time. Well, what's causing that decimal point to move is multiplying. Take and divide the numbers going backwards. So take your 123.4 and divide it by 1,234. You actually get 0.1. Take the 1234 and divide it by 123.4. When you do that, you get 0.1 again. Try this next one, 1.234 divided by 12.34. Again, you're going to get 0.1. What you're actually doing each time is multiplying by 0.1. So this is geometric. You're multiplying by 0.1 each time. So this is going to be 0.1234. This is going to be 0.01234. And this is going to be 0.001234 when we multiply by 0.1 each time. Go ahead and try this one, please. Go ahead and try this one, please. So when you try this one, the first thing that I would look for is arithmetic. How am I getting from 1 to negative 2? Well, to get from 1 to negative 2, I would have to subtract 3. Negative 2 minus 3 is not positive 3. 3 minus 3 is not negative 4. So I know right away that it's not arithmetic. So now you're going to try geometric. Well, it looks like maybe there's like some sort of like 1 or negative 1 in there. But the easiest way to test geometric is to divide going backwards. Negative 2 divided by 1 is negative 2. Negative 3 divided by negative 2 is negative 1.5. I know right away because these two numbers are not the same when I divide it going backwards. I know right away that it's not geometric. So therefore, it is a weird neither pattern. The pattern is consecutive numbers with every other one being negative. So positive, negative, positive, negative, positive, negative, positive, negative. And we're just adding 1 each time. So 6, 7, 8. So for the pattern, I would just describe it as consecutive numbers, meaning that they're in a row, consecutive numbers with alternating negative signs. Go ahead and try this last one on your own, please. Go ahead and try this last one on your own, please. So some people might just be able to see it right away. Negative 20, negative 16, negative 12, negative 8, negative 4. What we're actually doing each time is adding by 4. Since we're adding by 4, this would be arithmetic. Our common difference would be a 4. So negative 4 plus 4 is 0. 0 plus 4 is 4. 4 plus 4 is 8. Now, if you couldn't figure it out just from looking at it, remember we could subtract going backwards. Negative 16 minus negative 20 is positive 4. Negative 12 minus negative 16 is positive 4. Negative 8 minus negative 12 is positive 4. Negative 4 minus negative 8 is positive 4. That's where we get our common difference of 4. So arithmetic, you're adding or subtracting the same thing each time. Geometric, you're multiplying by the same thing each time. Neither is just a weird pattern.